Yeah. All right, ratio between two data sets. The two data sets are graphed as ordered pairs, and then we see if there's any trend in them. Okay, we want to see, how things are affected. And then a lot of people do different studies. Obviously, with you know this COVID-19 thing you might have heard about. There's multiple studies going on about different medicines, different procedures, different processes, what works, what doesn't work. But right here, this is a case. Weekly homework hours, grade point average. So this person does homework 4 hours a week, has a 1.5 grade point average. This person does homework 2 hours a week, has a 1.25 grade point average. Okay, over here, this person does 16 hours of homework and has a 3.75 average. Okay, so according to this trend, the more homework you do per week, does that help or hurt your grade point average? According to this data, it says it helps it. Okay, because you can follow the line. The more homework the person does, it seems to be they have a higher grade point average. So that would be a way to compare two sets of data. Okay. All right, now I think this is the one on here. That's that next one right there. Okay. All right, we didn't really have to answer anything about that. Also, you got to be able to read a scatter plot. Okay, you got an x-axis, you got a y-axis. Now, you see this little break? That just means you got a wide gap before the data picks up. So we don't want to, list out all the way to 46. So we put that little gap there. Same thing with the calories. The first one here is 250. We don't want to go 0, 10, 20 all the way up to 250. So we put a break there. How many calories are in the smoothie that contains 56 grams of sugar? All right, look at it. See what you think. You need to be able to interpret a graph. Just read it where it's at. All right, what do you got, Alex?
270.
He says 270. So yeah, so you go to 56 here. It's in between 54 and 58. There's only one point there, which is right there. And so that says 270 calories. All right, that's the only answer. You can't have anything else. All right, how many grams of sugar are in the smoothie that contains 320 calories? So instead of giving you sugar, they give you calories. Is there a point, or is there a smoothie that has 320 calories? Austin?
70.
70. So it's this one right here. So you go down 70 grams. 70 grams. What tends to happen to the number of calories as the number of grams of sugar increase? Well, does the number of calories go up, go down, or does it not seem to affect it at all? Okay, what would you say, Austin?
Goes up.
Yeah, it tends to go up. So I would say that. It tends to go up. So the calories increase as the grams of sugar increase. Okay. The calories increase as the grams of sugar increase. Okay. All right. Correlation is a relationship between two data sets. You can use a scatter plot to describe the correlation. So there's positive correlation, there's negative correlation, and there's no correlation. Okay. So a positive correlation goes uphill. Okay, and they're going to be grouped somewhat similar to a line. So the points lie close to a line. As x gets bigger, y gets bigger. Okay, so here would be a case. Think about this. The number of hours worked, say in a week, and your pay. Should there be a positive correlation? Yeah, I hope the more hours I work, I don't get less money. Okay. All right. Negative correlation. It's going to be going down. Well, we got to think of something here. I got to come up with one. What would be one here? Is something?
Naughtiness. And gifts you get for Christmas.
Okay, as your naughtiness increases, okay, that's pretty good. Your number of gifts should decrease. Okay, so that would be here.
I don't feel like singing Christmas songs.
We should play Christmas music in the back.
We should.
Please make
We'll do it
Check
later. All right, so that would be a case. So the badder you are, you should get less, theoretically less gifts. And now you're going to get, honestly, you're going to get some things that show no pattern. Okay, so what about your shoe size?
I was just going to say that. That was from the old textbook.
Yep, and your GPA. Should those be related?
No.
No, they shouldn't. No. So, hey, I wear a size 10. You should have above a 3.0. No, it has absolutely no bearing. Okay, so things have no correlation. So that there's things that do not affect one another. There are things that have a positive correlation. There are things that have a negative correlation. Okay? Negative just means it's going downhill. Okay, the more of one, the less of another. Positive means the more of one variable, the other variable also increases. Okay. All right, describe the relationship between the data and each set. Basically, is it positive, negative, or no correlation? That's all we're doing. What do you got? Positive, it's going uphill. Speed and stopping distance. So as you go faster, the amount of distance it takes to stop is going to increase. Also, make sure it makes sense, common sense wise. Does that, you're going 80 miles per hour, it's going to take you longer to stop than if you're going 20. So all you got to do is say positive correlation. Positive. And now this one, they give you the graph, which helps determine whether it's positive or negative. Temperature and coat sales at a store. Now you got the graph in front of you. Does that make sense? So as the temperature gets hotter, okay, Mason?
Negative.
Negative. As the temperature gets hotter, people aren't buying coats. They're buying swimsuits and floaties. I don't want to think about that. So it goes up. You're not really buying a lot of coats. If it's cold, people are like, I'm cold. I need a coat. Negative correlation. Negative. Correlation. Okay, so that would have a negative. And then graph also indicates that. Okay, lines of fit. So we have things that look like lines. We create lines with them. All right, when data shows a positive or negative linear correlation, so it's going uphill or downhill pretty close to a line, you can model the trend with a line of fit because, like it says, a line of fit is a line drawn on a scatter plot that is close to most of the data points. All right, let me go back and actually flip it over back to the other side here for a second. There are good lines of fit and bad lines of fit. And you don't need to draw these on here, but take a look here. Lines of fit do not necessarily have to go through points. Sometimes they will, sometimes they won't. But if I put a line through, is that a good line of fit for that data? No, you probably do better. So there are different patterns, and we kind of try and get as many above and below the line as we can and kind of see if we can do that. So this one down here, a good line of fit. So if I draw a line through those, first 2 points. So I draw a line through there. Is that a good line for that data? That was awful, right? Okay. So I want to make sure now, sometimes the first and the last one might work. I would say that's a pretty good line. Okay, you got about equal amount above or below. Okay. So, but you got to have some, what we also call outliers. So if I draw a line through, like you say, hey, I think I can get a line through these 3 points. Was that a good line? No, it hits 3 points though. And you got some above it and below it, but it doesn't model the data. So using a line to fit the data. So you're going to make a scatter plot of the data. We're going to decide whether the data can be modeled by a line. And draw a line that it fits appears to fit the data closely. There should be about as many points above as below it. And we're going to write an equation using 2 points in the line. The points do not have to represent actual data pairs. I think we're going to make sure they do, though, just to make life a little bit simpler. And then we're going to make them lie on the line of best fit. So first thing we got to do, you got that information there. First of all, let's plot the line. All right, so let's see what we got. On the x-axis, let's label our axis. It's going to be the year. And we start at 0, and we got 1, 2, 3. Can we go every 2? Will that make it or not?
No.
9, 10, 11, 12, 13, 14. A little bit short. So 3, 4, 5, 6, 7, 8, 9, 10. Now here's where you really have to make sure your scales are appropriate, okay, and correct. We go from 9 million to 89 million. I want to kind of make it as wide as I can, but not miss anything. So we got also 0 here. And whatever I make this first line, I got to go up by that increment. So if I make that 10, I got to go up 20, 30, 40, 50, 60, 70, 80, 90. So going up by 10, is that going to work?
Yeah.
Let's do that. So let's go up by 10. So make my first line 10, next line 20, 30, 40, 50, 60, 70, 80, 90. Now plot your points. I'm going to plot them in red. 0, 9 will be right there. 121. 226. 333. 443. 553. 671. 776. 889. Okay. Now, when you're dealing with real data, it's not going to form a perfect line, but it's going to come close to that line. Does that appear to be forming a line? All right. Now, for our sake, it is going to be easier to find 2 points that we can draw this line through that will give us the line of best fit that we call. All right. Now, I got a little bit of an advantage here because I can erase real easily. So you just hold on for a second. So let's take a look here at what could potentially work. That's pretty good there, right? I think that one is not bad, but I'm going to see here. And so I want to find 2 points that it's going to hit. So I'm going to use, let's see, I got to make sure. Okay. Well, let's see. The only thing is I don't have. Okay, I like that. Here's 2 points I want to use on that line. Right here and right here. Okay, so go ahead and draw in that, sketch in a line. And I hit that 3rd point and then the next to the last point.
226 and
Yeah.
776.
So let's write down those points. So I use this one, 226 and
776. Yep.
776. All right, what does it ask us to do? It says write an equation. The table shows a total number in millions of subscribers to a video sharing website X years since 2010. So in 2010, there were 9 million. In 2011, there were 21 million. Okay. Write an equation that models the total number of subscribers as a function of the number of years since 2010. Interpret the slope and y-intercept of the line of fit. Okay. We got to come up with an equation. This was our whole last test. How do I find an equation given 2 points? Okay. Mason?
M equals y, 2 minus y1.
Got to find the slope. Now I am going to put it in y equals mx plus b form. So we have to find the slope. You got plenty of room underneath it. So we're going to do m equals y2 minus y1 is 76 minus 26 over 7 minus 2. Now, when we are dealing with these data sets and you're doing a quiz or you're doing a homework, people are going to choose different points. They're not always going to work out to be nice whole numbers. This is a case where a decimal might be acceptable. Ellie?
Wouldn't 226 be the first one because it was first one?
What do you mean the first one?
Like, you put 76 first, so.
And you want to do 26? Should get the same answer.
Okay.
Shouldn't matter.
I didn't know if I would be wrong if I put.
No.
you get it. Your signs will be different, but in the end, they'll be the same.
Right. And in the end, we'll get the same answer. Well, and this one actually surprisingly works out nice because what's 76 minus 26? 50. What's 7 minus 2? 5. And what's 50 divided by 5? 10. So I get a nice number, 10. You know, this is like I said, this is a case where you could get a decimal. We'll just have to use that. Because we're not really graphing it. We're not, we've already got the line drawn. I just need the slope. I need the rest of the equation. So I get 10 for that. Now remember what we do from here. This is where we use y minus y1 equals m times x minus x1. And I pick one of the points and I use the slope as 10. Let's pick the first point, which is what, 226? So I got 226. I got m equals 10. All right, it's been a little while here, so shake off some of the rust. It's going to be y minus, put the y with the, the y1 is going to be 26. M is 10. And then we got x minus 2. All right, we want to solve that to get y by itself. If you know what you're doing, distribute. Go ahead. I'll finish it here in a second. There we go. Okay. All right, so I distribute the 10. So I get y minus 26 equals 10x minus 20. Got to do one more thing. I got to add 26. So I get y equals 10x plus 6. All right, that is my equation. Okay. So, the company wants to evaluate their subscriptions. So they got to make predictions based upon their data. So their data says we can use this line to, figure out 15 years from now, what should be our number of subscribers? 20 years from now, what should be our number of subscribers if this trend continues? All right, you are asked to do two things. Interpret the slope and the y-intercept of the line of fit. Interpret means what does it mean in this situation? I know the slope is 10, and I know the y-intercept is 6. What does that mean, though, in this according to the number of subscribers in the year since 2010? Any ideas here? What does the slope of 10 mean? Griffin?
You get to like million subscribers a year.
Exactly. That's exactly what it means. It means, and since it's positive, so the number of subscribers is growing by 10 million per year because it is 10 over 1. Okay. If it was 10 over or whatever, 5 over 2, it'd be 5 million every 2 years. But this would be, okay, so the number of subscribers is growing by 10 million per year. That's like kind of like my TikTok subscribers is growing per day by about 10 million. So number of subscribers is growing by 10 million per year. All right, what does the 6 mean though? What does the 6 mean? According to this line, what does the 6 mean? Okay. What is the x value at your y-intercept?
Years.
Your x value is years, but for the y-intercept, the x value is always a certain number. Or for the y-intercept, the x value is always a certain number. It's always a 0. Okay, so here's what you got to watch, because this may not match up exactly with the data. Because remember, this line does not match up with all the points. We only drew it through 2 points. So according to this, your y-intercept is the point. Let me write it like this. 0, 6. 0 means the number of years since 2010. So according to this data, in 2010, how many subscribers were there? 6 what? Million. Okay. So in 2010, which means x equals 0, there were 6 million.
It says 9.
Okay. That's what, let me see if I can explain this. Not every set of data will give you a value for every year. Now, this one does say 9, but we picked these 2 points, and according to these 2 points, okay, we got that line. So my data is going to be a little bit different than what the actual value is. You're right. In 2010, there were 9. But this line, okay, according to this equation, it says in 2010, there were 6 million. Okay, it doesn't match up exactly? No, none of it will, but it'll give you an approximation. Okay, so you got to watch that. Okay, I know that can be a little bit confusing, but according to this information, in the year 0, there was 6 million. Okay, what was the actual number though? Actual number was 9. Okay, but we're using this line to make predictions. So think about this. And according to this, in 2020, how many subscribers should there be? How could we figure that out? In 2020, how many subscribers should there be? What would you do? Mason?
Just times it by 2.
Times what by 2?
6.
Not 6. So think about this. So in 2020, how many subscribers? So this is where this line comes into play. X is the number of years since what? Or wait, let me change that. Instead of 2020, let's actually use 2030. Right? In 2030. So in 2030, how many subscribers will there be?
Don't you just have to put 30 in for that?
Okay, now this is where we got to really read. Do we have to put the 30 in for the X? Actually, what does X represent? It says right there, it's the number of years since what? 2010. So in 2030, how many years will that be? 20. So you plug in 20 for what? X. So you let X equal 20. I thought did you say 30 the first time?
I guess so. Yeah.
Okay. So you get Y equals 10 times 20 plus 6. And what does that actually come out to be? What's 10 times 20 plus 6?
206.
206.
Oh,
So there's going to be 206 million subscribers in 2030 if it continues on that same trend. Okay, so that's kind of how that's used. All right, positive correlation, negative correlation. All right, page 209, 1 through 6, and number 9. Get a few of those done here. Get a few of those done. Now, some things will have no correlation.